Scientist Jacques Charles is credited with discovering the relationship between absolute temperature and volume of a gas when the pressure and amount of a gas are not allowed to change. These conditions are easily met if we have a closed container, so the amount of gas stays the same, and if that container has a variable volume, such as a syringe or a balloon, and the pressure of the gas will equalize with atmospheric pressure, and so therefore the pressure remains constant. It's going to be important for us to understand what we mean by absolute temperature. When we look at absolute temperature, we will only use the Kelvin scale. The Celsius scale has negative values and a value of 0. At ambient conditions, we cannot use Celsius. So all of our temperatures must be in Kelvin when we look at this relationship. So what Charles discovered was that volume and absolute temperature are directly proportional. And if we look at this example here of our original condition, where we have a volume of 1 liter and an absolute temperature of 200 Kelvin. We have a fixed amount of gas. This is a closed container, and our volume can change because this plunger can move up and down. If we heat our container, the temperature will go up, and if we double the temperature to 400 Kelvin, our volume will double to 2 liters. So we see in this example that temperature, absolute temperature, and volume are directly proportional. So let's take a look at the actual mathematical relationship. Vi, our initial volume, over Ti, our initial temperature, so that in this case would be 200 K and 1 liter, is equal to Vf over Tf, so our final condition, so our final volume and our final temperature. So since there are 4 different variables, there are 4 ways we can rearrange this equation depending on what we're solving for. You will always be solving for one physical property, and you will be given 3 others. So the very first thing you want to do when you recognize you're given an initial and a final condition, and you're looking at volume and temperature, you realize you're going to use Charles's law, identify what each variable is. Is it an initial volume, a final volume, initial temperature, final temperature? And then, once it's clear what 3 variables you have, you'll know which of these 4 equations to use. So you may want to pause this video and write down these 4 different variations of Charles' law. And then you will also want to have very handy the conversion between Celsius and Kelvin. So to get Kelvin from Celsius, you add 273 to the degrees in Celsius. Charles' law must have its temperature in units of Kelvin.